Good morning, class. Today we are going to learn about quadratic equations. Okay, so before we start, do you ever heard this term before? Do you have any idea what does it means? Quadratic equations. Let me tell you quadratic equation through the concept of polynomial. What is polynomial? Polynomial is basically mathematical expression that consists of variables and constants. Consist of variables and constants in addition or in subtraction. In addition or in subtraction. Second point for polynomial is variables. Variables power should be a whole number or a non-negative integers. Variables are like x, y, z, the alphabetical numbers. Means the alphabetical terms like x, y, z. These are variables. Variables power. These are the power. X power, y power, z power. These are the power. They should be a whole number or a non-negative integers. Let me tell you what is whole number. Whole numbers and non-negative integers both are same things. Whole numbers and non-negative integers are 0, 1, 2, 3, 4, 5 up to infinite. These are whole numbers. And fractional numbers, negative numbers and decimal numbers, these are not whole numbers. Okay, these three are not whole numbers and these are whole numbers. Fractions like 1 upon 2, 4 upon 8, 5 upon 6, these are fraction numbers. And negative numbers are like -1, -4, -8, -6. These are fractional numbers. And decimal numbers are 0.1, 4, 0.1, 0.8, 0.7. These are fractional numbers. So, you know what is polynomial? Polynomials are expression that consist of variables and constant in addition or in subtraction. Second point is variable power should be whole number and non-negative integers. So let me explain this to you through some examples. So this is our example. Now you tell me, is this first is a polynomial? Two conditions for polynomial. First condition is variable and constant is in addition. Okay, first condition, follow this expression. Now second is variable. This is a variable x. Variable power should be a whole number. Here this x power is 1. So 1 is a whole number? Yes, 1 is a whole number. So both these conditions are follow for this expression. So it's a polynomial. Now in this expression, tell me, is it a polynomial? First condition is variables and constant in addition. Okay, variable and constant is in addition. First condition follow for this expression. Second is variables power should be a whole number. Here power is 2, power is 1. Now tell me 2 and 1, these are whole number or not? Yes, 2 and 1 are both whole numbers. So this expression is a polynomial. Yes, polynomial. Now tell me, is this a polynomial? 1 upon x plus 4. We can write 1 upon x like x power minus 1. We can also write 1 upon x as x power minus 1. So we have studied that negative variable power can't be in negative because it's not a whole number. Minus 1 is not a whole number. So this is not a polynomial. Now you tell me, is this a polynomial? First condition, variable and constant in addition. Okay, first condition follow for this expression. Now tell me second condition. Second condition is variable power should be a whole number. Variable power is half here. So half is a whole number or not? No, half is not a whole number. This is a fraction. So this can't be a whole number. So no, this is not polynomial. Now tell me, is 7 is a polynomial or not? Now tell me, first condition, 7 is a constant. Is there any variable? Yes, x power 0. X power 0 is basically 1. We can write x power 0 or we can simply write 1. Here x power is 0. So this is a variable. First condition is follow for this expression. Second condition is variable power should be a whole number. 0 is a whole number. So second condition is also follow for this expression. Yes, this is a polynomial. Now tell me, is this a polynomial? Yes, this is a polynomial because variables and variables are in subtraction and variable power is a whole number. 3 and 1 is a whole number. So this is a polynomial. Yes. Now tell me, is this a polynomial? X power 1 plus 3. Yes, variable and constant in addition. First condition follow. Now second condition is variable power should be a whole number. Yes, second condition is follow here also. Now this is also yes. Now tell me this 8th example. 2x square plus 1 upon x. Here variable is in addition. Okay, so first condition is follow. Now tell me, is second condition is follow for this expression. Here x power is 2. This is a whole number. Okay. This can be write as x power minus 1. We know that this can be write as x power minus 1. Here x power minus 1 is not a whole number. So second condition is not follow for this expression. So this is not a polynomial. Not a polynomial. Now, I think we know what is polynomial and what is not polynomial. Now, let's move to our next topic. Let me tell you what is degree. Let's understand degree concept through, let me take this example. Here we are taking this example. 3x square plus 2x plus 1. This is a polynomial. Okay, we studied here. This is a polynomial. Now tell me, this is a variable, this is a variable. Here power is 2 and here power is 1. Degree is basically maximum power of the variable. Maximum power of the variable. Now tell me, maximum power of this polynomial. 2 or 1? 2 is greater than 1. So maximum power is 2 here. So degree for this polynomial is 2. Degree of this polynomial is 2. Let's take another example. Let's take this example. 5x cube minus x1. Now tell me maximum power of the variable. Here variable power is 3 and variable power is 1. 3 is greater than 1. So degree of this polynomial is 3. Now take this example. Example first. X power 1 minus plus 5. Now tell me degree. Here only one variable and the power of this variable is 1. So degree of this polynomial is 1. Okay, so now I am going to tell you difference between polynomial and equation. Difference between polynomial and equation. Let's take this example. 3x square plus 2x plus 1. This is a polynomial, you know. Here, if we equate this polynomial with 0, this will become an equation. If we equate polynomial with 0, it's become equation. And if we remove this equate 0 from the equation, it's become polynomial. This is basically the difference between polynomial and equation. If we equate any polynomial with 0, it's become equation. And if we remove this equate 0 from any equation, it becomes simply polynomial. This is a degree 2 polynomial. We know this is a degree 2 polynomial. We can write it a polynomial. Here, now I'm going to tell you one thing. These degree 2 types of polynomial are known as quadratic polynomial, quadratic polynomials. Degree 2 type of polynomials known as quadratic polynomials. Degree 3 type of polynomials are known as cubic polynomials. Cubic polynomials. And degree 1 type of polynomials are known as linear polynomials. Now, these are the names of these polynomials. This is a quadratic polynomial, this is a cubic, and this is a linear. Now, tell me, is this a quadratic polynomial? Yes, this is a quadratic polynomial. And if we equate this polynomial with 0, it's become quadratic equation. This has become quadratic equation. Our entire focus will be on quadratic equations, degree 2 equations for this chapter. Okay, so you know what is degree, what is polynomial, and what is equation. Now, one thing, always remember, degree also tells us about how many roots this equation can have. This equation can have. What are roots? Okay, now I am going to tell you what are roots. Roots are basically the number that makes the equation 0, or you can say number that satisfies the equation, Roots are basically the number that makes this equation 0. Okay, now let's understand this by one example. So this is our example. Now solve this for x. Here x square is equals to 60. When we remove this square, it gives plus minus and under root on the other side. You know that under root 16 is 4. This x gives you two values, plus 4 and minus 4. This This x, these are the numbers. These are the numbers that makes this equation 0. So they are basically roots. These x values plus 4 and minus 4 are basically known as roots because that makes this equation 0. Let me prove this to you. Put x power 4 in equation. X square minus 16 equals to 0. 4 square minus 16 equals to 0. 0 equals to 0. LHS equals to RHS. This satisfies our condition that these numbers satisfies the equation. These numbers that makes the equation 0. When we put 4, it makes this equation 0. So these are basically roots. These two are roots of this equation. These are also known as roots. They are also known as zeros. And they are also known as solutions. Okay. So, you know what is roots now. Here we understand that degree also tells us how many solution roots this equation can have. So you know here degree is 2. Degree is variable's power. Here it's given that degree is 2. So how many roots this equation have? 2. So basically degree tells you how many roots any equation can have. Now you know what is roots and what you know how, so now you know what is roots. Now let me tell you how can you find these roots. How can you find these roots? How to find roots? There are two methods to find roots. First method is factorization method, and second method is quadratic formula method. Now first let's understand what is factorization method. Factorization method, I am writing a general form for quadratic ax square plus bx plus c equals to 0. This is a general form of quadratic. Now a, b, c are the coefficients of this equation. These are the coefficients. A, b, c are the coefficients. And here x is a variable. Now factorization consists of 4 forms. 4 forms of factorization. First form is when this a, b, c terms are positive. When a, b, c are positive terms. Second form is when A and C are positive terms and B is a negative term. This is our second form. And third form is when A and B are positive terms, and C is a negative term. Okay. And the fourth form of factorization is when A is a positive term and B and C are negative terms. So let's start with our first form of factorization. First form, where A, B, C are positive terms. Now let's take one example. So this is our first form example. Okay, so our first step, write the coefficients. This is our equation. I am writing general form ax square plus bx plus c equals to 0. Now first step is to compare their coefficients. Here a is 1, b is 8 and c is 15. A, B, C are positive terms. A and B and C both these are positive terms. Now second step is first step, second step is to multiply first and last term. A into C, 1 into 15. This is our product term. Product term is 15. Third step third. Step third is to find sum. Sum is the addition of two numbers in such a way. Sum is the addition of two numbers in such a way that their multiply gives you 15, the product term. And their add up gives you 8, the middle term. You have to find two numbers that their multiplication of those two numbers give you 15, your product term, and the addition of two numbers gives you 8, the middle term. Now how can you find these two numbers? Use factorization. You have to factorize this product term. Factorize product term. 15 factors 3 multiply 5 is 15. 5 multiply 1 is 5. These two, 3 and 5 are the factors of 15. Now, by these factors, the possible combinations are, first combination is when we add these two factors, 3 plus 5, 8, and multiply these two factors, 3 into 5, 15. So, this combination is also satisfying our condition. Here, multiply gives you 15. Multiplication of those two numbers give you 15. Here, 15. Add up of those two numbers give you 8. Add up is 8. Now, your fourth step is to split the middle term using these two numbers. X square plus 8x plus 15 equals to 0. Now split using these two numbers. 5 plus 3. Why I am writing 5 plus 3? Always remember this point, that the greater term writes first and smaller term writes second, so that you can get correct answer. Plus 15 equals to 0. Now multiplying x, compare x, take common x, we are taking x common plus 5. Now, here we are taking 3 common. We are trying to make these brackets common so that we can pull out a single common factor from here. X plus 5 and x plus 5 is a common factor, so we are trying to make these brackets common so that single factor can be pulled out. Now other factor is x plus 3. X plus 3 and x plus 5 are the two factors of this equation. Now how can you find x? X plus 3 equals to 0. X plus 5 equals to 0. Equate these factors with 0. X value is minus 3. X value is minus 5. You know, when degree tells you how many roots equation can have. Here, this equation have degree 2. So, roots this equation have is 2. There are two values of x. Now, let's move to our second form. Second form of factorization. Here I'm writing when A and C are positive and B is negative. Writing general form of quadratic ax plus bx plus c equals to 0. This is a general form. Now I'm taking one example so that you can understand